Good morning, everybody. Thank you for joining us. I am Renee Barassa. I'm the Director of Communication and Education here at the Interstate Commission on the Potomac River Basin. We are also known as ICPRB. You'll be hearing that a lot this morning. We're excited you have joined us for today's webinar. It's called Unsung Heroes of the Potomac River, American Eels. It is the third in our 5-part webinar series celebrating our 85th anniversary. You'll see on the screen the dates and subject matter of future webinars. If you'd like to sign up for any of them, you can visit potomacriver.org/webinars, and there will be a link to registration for all of them there. I'll cover some logistics while folks are rolling in, and then I'll introduce our speakers. To prevent any accidental unmutes or videos, you will not have the ability to come off mute or turn on your video during the main part of the presentation. However, once the presentation is over, we will change the settings and you will be able to come off mute and turn on your video to ask a question. We encourage you to join the conversation at this point. In the meantime, if you think of a question during the presentation, please feel free to put it in the chat and we'll address it at the end. The webinar is being recorded and will be sent to you via email later today, as well as posted on our YouTube channel. It looks like people are still rolling in, but while they're rolling in, I'm going to start a fun poll. See if that comes up. There we go. So while you're answering that poll, I'm going to introduce our speakers. Our speakers today will be Mike Felkman and Megan McClougherty. Gordon Felkman, also known as Mike, is the Associate Director of Aquatic Habitats at ICPRB. He is responsible for evaluating and assessing the habitat quality and biological health of communities within Potomac waters. His work coordinates the cooperation of federal, state, academic, and local partners to find and implement solutions to environmental issues. Megan is the Ecological Technician at ICPRB. She is a certified associate ecologist who is particularly interested in the effective management and restoration of freshwater ecosystems to meet both the needs of humans and aquatic life. She has experience with groundwater, surface water, and biological monitoring, as well as a variety of wildlife survey techniques and data analysis and visualization. At this point, I'll introduce our first speaker, Michael Nardelili, the Executive Director of ICPRB. He's going to give us a short history and overview of the organization, as well as a background on ICPRB's work around aquatic life. He'll also answer your poll question.
Okay, thanks, Renee. So everybody has now voted, I assume, and 3 choices there. The correct answer is Sigmund Freud. Which I guess explains a lot about his subsequent work on human beings. But yeah, he started out as an ichthyologist studying eels. Okay, so let's see. Next slide. Okay, let's start off with who we are. The ICPRB was approved by Congress in 1940 as an interstate compact, and we were originally focused on preventing and rendering harmless pollution of the waters of the Potomac River Basin. And then in 1970, the compact was amended to include water resources and related land use. The Potomac River watershed is about the size of Switzerland, over 14,000 square miles, and it is part of the broader Chesapeake Bay watershed. The signatory jurisdictions to the compact are Maryland, Virginia, West Virginia, Pennsylvania, and the District of Columbia, but not the United States. We have no regulatory authority, but we've been around since 1940 and issued a number of reports and studies that have really influenced policies throughout the Potomac River Basin. Next slide. So our major focus areas are 4. We focus on drinking water and water resources, water quality. So the first one really is quantity, and the second one is quality. The third one is aquatic life, and finally communication and education. These are our major focus areas. Next slide. So a couple of projects that we have been involved in that we're very proud of in the aquatic realm is that we signed an agreement in 1995 to reestablish migratory fish access to their historic spawning grounds upstream. The resulting fishway was completed in January 2000, and the program also included an education component. And unlike other native fish, shad continue to thrive today. As you can see by that chart, the shad report card showed that the abundance of shad disappeared in the river. For many years, there was very much a thriving shad industry. Matter of fact, George Washington made more money from fishing than he did from farming. But the river was overfished, and we were very proud to play a role in bringing shad back to the Potomac River. Next slide. So another project of ours is called Chesapeake. So this is the Chesapeake Basin-wide Index of Biotic Integrity. So we map stream health in the Chesapeake Bay watershed according to a number of different factors. This is used by the Chesapeake Bay program to track stream health, and it is calculated from stream macroinvertebrate, little creek critters, samples that are collected by 24 monitoring programs since the year 2000. And we periodically assemble the data and calculate the index. We are just on the verge of releasing our new data. So that's why that map there is draft form, but we anticipate it going final very soon. Next slide. So what about biological stressors in identification studies? So ICPRB helps the states analyzes the causes of harm to aquatic ecosystems to help identify sources of pollutants. The goal is to understand why a biological community is struggling and to inform restoration and protection strategies. So what are stream stressors? Well, you can imagine sediment that flows down the river and may cause problems for the aquatic community. Oxygen levels may drop, and that certainly influences the support for life. Nutrient loads, you can have too much nutrients in the system, which lead to harmful algal blooms, and habitat loss due to development and other factors. Next slide. But we have other activities. We actually do a drought monitoring of the Potomac River because there is a requirement for an environmental flow by of 100 million gallons per day. And even though the Potomac River is the primary drinking source for the Washington metropolitan area, we want to make sure that the water suppliers don't drink the river dry. And so they have a target that they have to meet and allow a 100 million gallon per day flow by so that the aquatic community downstream and in the Chesapeake Bay survives. We are also focused on reducing winter salt use. As winter approaches now, we are very mindful of the fact that people should only be using maybe a coffee cup full of salt on an average driveway or a sidewalk, and then also to sweep it up after you use it. And then we also do a number of public events and education. One of our primary ones is what we call Walk in the Woods, and those are designed to bring people to the watershed and always be very instructive by a lead scientist or other person will be able to explain what you're looking at. So next slide. So with that, I will turn the program over to Mike Selkman, our Associate Director for Aquatic Habitats.
All right. Thank you, Mike. So I'm hopping on the camera just for a brief second to show that this is a real person talking. This is not AI or any other craziness going on. I'm going to save some bandwidth and disappear again, but thank you all for coming out. And really excited to have the opportunity to talk about this because this is a fun topic to get to talk about. So there I go. So right off the bat, the eel question, and it's sometimes known as the last great unsolved question in zoology. It's pretty funny. After this presentation, hop on Google, type in the eel question. You realize that this is a question that's 2,000 to 3,000 years old, probably older. Um, I was particularly interested in this because I've always been sort of interested in that transition of philosophy and folklore to, you know, the scientific era, and then kind of how we understand our stories today under the um, modern science. And, so this is a good starting point is this eel question. Simple things that we take for granted. What is an eel? How do they reproduce? And where do they come from? Have been asked for a very long time. The term scientist was coined around the 1830s, and we think of people like Darwin, Mendel, Pasteur, Mendeleev. Um, all of them were unlocking what at the time must have been an exciting period to be alive. Things left and right, the cellular biology, the concept of evolution and heritable traits, genetics, all these things, the periodic table, all these things were just, it seemed like we were figuring out the world. And then there were eels. Max Schultz, who was one of the founding biologists to develop cell theory and microscopic anatomy, on his deathbed said, all these important questions have now been settled. All the low-hanging fruit are gone, except for that eel question. And I just love that when it seemed like the world was opening up, there was still this pause. So we go back to the beginning. The ancient Egyptians believed that eel came from the mud of the Nile. When the sun hit that warmed mud, that they would emerge out. And because of that, eels were linked to Atum, the creator god, and often eel were mummified and were presented, I guess, in sort of in honor of this creator god circle of life. But it was also a sign of fertility. These things were abundant, and nobody knew where they came from. One of the things I found very funny about this is so that's a touch of the ancient Egyptian folklore. But growing up, I remember hearing the stories of eels emerged from farmland in Frederick County. Some of these old folklores have really been around a long time. The Mediterranean mythology, the Greeks, particularly Jupiter, if for those of you that are into this period of mythology, Jupiter had a lot of children, and that unknown paternity, it was often just written off to you are the child of Jupiter. And they believed eel were as well. Eel were these things that just emerged into the wild. A Greek naturalist and philosopher Aristotle also incorrectly believed that these were spontaneously generated from the mud from the earth. And even looking at the Roman myth with Pliny the Elder, he believed that they were born from the entrails of earth, and that if it didn't come from the mud, then pieces of the eel, the scales, these things that fell off as they slithered over the rocks, would just basically generate a new eel from that. So again, there's this idea that these things just had to emerge from somewhere. Northern European mythology. And again, you start reading these mythologies and you're looking between the lines, trying to figure out if there's some biological anecdotes. And I'll start with sort of the English folklore. It was a Christian food source because a lot of the yellow eel that were being captured, they don't have reproductive organs present, or at least not easily detectable at that point. So they were deemed a clean food, and depending on where in the religious spectrum one fell, fish on Lent, um, this was the cleanest of the fish because they lacked the reproductive organs that were kind of cast things with reproductive organs in a negative light. The Scottish have some phenomenal um, folklores, some of which being, when these eels would wash up on the shores dead, um, there would be beetles crawling through them. And they believed that there was a terrestrial stage where the young of the year were actually born of beetles and they would go back to the ocean and develop into eels. There's also some mythology that talks about them being born of horsehair when it came in contact with seawater. Um, my favorite stories are the Celtic stories where it was a good omen to have an eel in your well. And we know now, kind of like a goldfish in a koi pond, that there was some benefit into having that eel present in a well like that. But they were believed to be fairies, kind of captive spirits that were a good omen. Um, what's pretty interesting, and we see that go all the way across the North Sea there. Oh, wait one moment. Okay, there we go. Um, but there's a Swedish story of the Brantevik eel. And in 1859, an 8-year-old boy threw an eel into a well to keep with tradition. And it was, as the story goes, it was recovered dead, partially decomposed. But when sent to an expert, they were able to age the eel at 155 years. Now, this is an exceptional case, but the morphology of the eel, it had gotten larger eyes, it had filled out its whole life, it was captive in this one thing. But the idea that, or in this one well, but the idea that these can last such a long time is pretty tremendous, and led to that folklore of these things being life and death and emerging from the earth. To hop over to the other side of the Atlantic, eel in the New World, this is kind of the first touch of the eel as being an unsung hero of the Potomac. The title of this is, and I'll give you guys a little tidbit about me personally. My great grandfather is John Howland, came over on the Mayflower. So I personally have to thank an eel at some point, because we think about turkey and corn and all these things that the Native Americans presented to help these settlers in the New World. The reality is, the pilgrims were taught to fish, and they survived off of eel in large part. Um, I want to read this real quick. One of the first things that Tisquantum or Squanto did was gift them an armful of eels. After their very first meeting, Tisquantum went to the river, and at night he came home with as many eels as he could lift in one hand, which our people were glad of. It was noted in one of the pilgrims in a diary later sent back to England. They were fat and sweet. He trod them out with his feet and so caught them with his hands without any other instrument. So there's two things I want to point out here, kind of reading between the lines. Think about the density of eel that would have had to have been present for somebody to walk along and kick these eel up and then to catch them with his bare hands. I don't know if anybody's ever had a day out on the bay or walking around at night in one of these rivers. It is hard to catch a slimy eel with your bare hands. So to think of how many must have been there and how good he was as a fisherman, this story makes me smile. But yeah, so this was the first kind of look at that being the hero of the New World to a lot of the settlers. So with that, sorry, here we go. Slides weren't advancing. This Thanksgiving, just spare a turkey, eat an eel. I say that, but I also know at the end of this presentation, we're going to talk about the kind of the collapse of the fishery, and I was really conflicted about whether or not I wanted to put this slide up. So take it with a grain of salt. So we get to the modern era, what I'd call this like scientific era. And there's really two people that are worth knowing, or two groups that are worth knowing. The first are a pair of Italian biologists that, from going out and sampling in the Mediterranean, found that the Leptocephalus brevostritis was actually the larval stage of the freshwater eel. Until then, each one of the different life stages of the eel were considered different species. So to link this almost planktonic life stage to the inland freshwater stage was a hugely significant finding, and that was 3,000 years in the making. Now, Johannes Schmidt heard this, and at this point, the Italians thought that eel were a Mediterranean species. They thought that their nursery ground, their spawning area, would have been in the Mediterranean. But Johannes Schmidt traveled all over Europe for, I guess, 7 years and saw that there was a lot of very similar sized larvae across all of Europe, and that it was likely not the Mediterranean that was the spawning ground. You would have expected some size differences. So from that, he put forward the hypothesis that you should go out to the middle of the Atlantic and take a look, taking samples and trying to find these larval eel. And as they got smaller, he knew he was heading into the right direction, presumably smaller and smaller until he found where there would be eggs or spawning eel. And his research, just because I'm a big fan of boats and I think there is much a character in these stories as the biologists themselves. There's the Dana 2 leaving apparently to the gills with coal, heading out for one of its many circumnavigations of the world. But this is what the data ended up looking like by using research vessels as well as kind of opportunistically using other research ships and commercial ships and things like that. They were able to take these samples and develop a map that looked like this. And when you looked at the size distribution of the young of the year, these larval eel, you see that the smallest ones were out here in the Sargasso, and that they gradually got larger as they moved towards mainland Europe. The other thing that he noticed was that the morphology changed as you got closer to the shorelines. So a simplified, kind of modernized view of that earlier map is this. We see that there's the Gulf Stream that is taking these larval eel, and they're either going east or going west to North America, and that's the American eel, Anguilla rostrata, or they're going across the Atlantic, and they are the European eel, Anguilla anguilla, and they were considered the same species for a long time. What's really interesting is what happens halfway across. So American eel and European eel can actually hybridize, and the hybrids exist exclusively in Iceland and in Greenland. And what's interesting, and this is kind of the cutting edge of the research right now, is that it looks like it's American males are always the father, while the European eels are the mothers in this situation. So what's kind of, why is this jumping? 1 second, sorry about that. So it kind of rose the evolutionary question, what's the difference between the American eel and the European eel? The European eel, its migration journey is more than 5,000 kilometers. It spends its larval stage up to 3 years, and it has more vertebrae, so morphological differences. But they are spawning in the Sargasso Sea, but with a more eastward distribution. The American eel only has to migrate 1,500 kilometers. Really, their larval stage is only lasting up to a year, and many times it's quicker than that. Fewer vertebrae, and again, they have the more westward distribution. It appears that the American eel get to this spawning ground first, and then the European eels show up, and the American eel are still there at the disco, and that's where the hybridization may occur. And when these two hybridize, it seems that the larval stage length is actually kind of intermediate between these two, and that's what creates that northern population. Really interesting stuff about how these evolved during the Panama land bridge. And if you're into this, the evolution and the speciation of these two eel is just a really fantastic read. Follow up if you're interested in the publication or anything. I'd love to talk more about it. I could dwell. But let's focus now on kind of the point of this presentation, the American eel. So there's this life stage that I've already kind of run through, where we go from the larva to the glass eel stage, in Elver, the juvenile eel, where they pick up pigment, the immature life stage, which is what most of us I would expect have come in contact with. This is what it's often used as bait eeling if you're a rock fisherman. And then heading out, ooh, let's keep jumping. Heading out in the fall, you have the silver eel migrating out of these freshwater streams, back into seawater, back into the Sargasso Sea, and so on and so forth. I want to spend a little bit of time just showing you guys how just dramatic the metamorphosis is of the eel through its life stages. So the leptocephaly, which translates to slim head, in its larval form is usually 6 to 8 centimeters. It was once its own species. And these are free floating, kind of drift feeding on marine snow. They're this like, it's paper clear. Again, I'd suggest if you're into this, hop on YouTube and look at some of these that are caught in the wild. It is just this tremendously clear ribbon, really fascinating. And then they'll turn into this glass eel. So it's the second morphological phase, still in that 6 to 8 centimeter range. But they're now nearly transparent. You start to see more of the vertebrae and the internal organs. But now they're starting to use their sense of smell to find fresh water. This is kind of that stage going from the Atlantic and they're entering into the estuary. And yeah, that things like the current and the tributaries are directing their upstream motion, but at this point they don't have the musculature, the strength to really navigate up stronger currents. So it's definitely moving into sort of that nursery sort of bay coastal environment. The glass eel will turn into an elver, and the elver is now moving even more so into all freshwater body types. We see the development of the jaw and the pelvic fins. The pigment is now established. They're starting to look more like their surroundings. They're still avoiding fast moving water, but their way around that is seeking complex benthic habitat. So you'll see elvers in complex cobble, boulder, grass beds, things like that, and they're able to use their long, slender shapes to navigate up and sort of defeat currents using local flow refugia. And at this point, you start seeing that their diet is shifting to more invertebrates, and they're kind of becoming more of the predator that we would know further upstream. The yellow eel, as I said before, this is the one that I think most of us would recognize as an eel, at least if you're Chesapeake born, you know, you've seen these your whole life. So that brownish yellow color establishes with the yellow belly. This is the longest life stage. So these fish are in the tributaries for anywhere between 5 to more than 30 years. And going back to the mythology of it, these are sexually immature fish. So when, you know, before that sort of 1830, 1860 range, when people were catching these and dissecting them, looking for their component parts, that's the fact that there weren't any reproductive organs is what made a lot of that mythology of these things being spontaneous, emerging from the mud, emerging from the earth. These yellow eels are active swimming, and they're opportunistically travel over land to seek out new habitat. Again, I remember stories growing up of when it rained hard, these guys were out in cow fields in Frederick County. They'll take that opportunity to navigate up into the mud to try and find the new pond, to find that new stream. So it's pretty wild. You run into these things just out on the flats. The other thing is that they're nocturnal and their activity is influenced by the lunar cycle. So when I ask people if they've ever seen these, I'm surprised the number of folks that haven't. But you'll catch them at night if you're catfishing or something like that. They show up in the river at nighttime. And then finally, there's the silver eel, and you can see that this is another pretty significant change in appearance. The eyes enlarge. They get that sort of darker, shinier appearance with a cream belly. You'll see that kind of camouflage, the light on the bottom, dark on the top with most pelagic fish. That's just camouflage for open water. These things are getting ready to go back into the middle of the Atlantic. So this is the only stage that was present with reproductive organs. And what's interesting is that the female silver eel was the first, talking about the European eel, but that was the first one that was found with ovaries. And that's when the connection between the silver eel and that reproductive stage was kind of documented. The male gonads weren't seen for I think it was a decade or two after. So feeding structures, they diminish. This whole time they have been putting on just feeding and feeding, getting ready for the migration out of these rivers back into the sea. And they're just putting on fat. A lot like a bear fattens up for winter hibernation. Silver eels will possess a thick fat layer under their skin, and it just made them a valuable resource. So humans have long realized that they're perfect for smoking, which preserves the flesh. And if you've ever watched any of these survival shows that are on TV now, like that fat to survive winter, to survive the hard periods, and to have something that preserves well. I mean, these things were critical to the Chesapeake region to survive the harsh winters. So Native Americans would build things like stone weirs and rivers to intercept them. And yeah, again, we look back to that story with the Pilgrims. You know, this was a fishery much like the shad fishery that indigenous populations were moving to areas that were choke points and bottlenecks to capitalize on capturing the silver eel because they were such dense energy packets. I mean, this was a top quality food, and that's why places like um, Brunswick, Maryland, formerly known as Eeltown or Eel Pot. The number of fish weirs that were right there around the confluence of the Shenandoah and the main stem Potomac upstream of Harper's Ferry is just astounding. And we see that there are these stone fish weirs that are still in place. There are also, you see the picture of the way we were, or the manner of their fishing, I'm sorry, that there were these in-stream traps to catch the eel as they migrated out. This was a huge food source in the bounty of the bay. There's lots of historical accounts from John Smith and others talking about how dense eel populations were. It's pretty amazing when you realize that 1 out of every 4 pounds of the seasonal biomass in the Potomac River was American eel during peak migration. That should just be an astounding fact if you remember little else from this presentation. When we look at the Potomac River and consider what's native, what's the river look like, what's a target for restoration, you know, and then we compare it to any sort of historical anecdote, you know, the fact that they're at 1%, 2% of their historic populations, there is a huge biological piece of the mechanism missing in this river right now. But culturally, extremely significant as well. The Potomac tribe in Northern Virginia, they're still making the traditional eel traps. This is Brad Hatch with the Potomac Museum. Highly suggest going down there and seeing the traditional fishing methods and all that. So you have the fish weirs as well as the traps. Moving into the colonial period, the areas that were migrationally significant to the indigenous populations became significant to the colonizing populations. Like I said, Brunswick is a great example of that. Was a transitory fishing ground that was established by, I believe it was the Dutch, it might have been the Germans, and then it became Eel Pot and then eventually Brunswick. But as food security and that westward expansion kind of stabilized, you started seeing the economic focus on the Potomac being more and more important. And in 1768, the General Assembly wanted the Potomac fish weirs destroyed because they were obstructing navigation. That's before the C&O Canal. So you start seeing these fish traps sort of being moved away, but more industry moving in. 1926, the Black Bass Act made the commercial sale of bass illegal. And that was just one more sort of nail in the coffin to these fish weirs that you still see if you ever go across the bridge, or really any of the bridges. There are remnants all over the place around the Harpers Ferry area. And basically, we're kind of in this area now that we know that from the confluence of the Shenandoah and the Potomac up to Cumberland, there should have been many, many eel, and that's just not what we're seeing anymore. And that's probably due to the modern industry where dams were being built for the purpose of watering the canal. Eventually, these rubble dams would be hardened to be cement faces that are taller than what the eel can pass easily. And hydropower becomes another player as the electrification of the Central Maryland area. We see how we use the river impacting the distribution and the ability of these fish to get upstream to where they've always been. So with that, I'm going to switch gears. And Megan, are you still there?
Yep, I'm here.
Take it away.
All right, I turned my camera on to briefly show that I'm also a real human person, but we're going to keep going on our journey through time here, starting around the 1980s and then through today with the most current trends. And so after decades of relatively stable harvests in the 1970s and into the early 80s, we saw a peak in the commercial harvest for American eels with a maximum annual harvest of just under 4 million pounds along the Atlantic states. And a lot of this was really driven by external demand. So in the previous decade, around the 1960s, the European and Asian eel fisheries basically collapsed. And so we had these external markets that were looking for a source to meet their ongoing demand. And over the course of about a decade, the price for yellow eel starts to climb, which really incentivized that commercial harvest. And a couple additional factors that were contributing to the decline during this time, although to a much lesser extent, are that American eel are a popular bait fish domestically, and there's also some amount of recreational harvest, which also peaked in the 1980s, although that's something that isn't well monitored in the US. From a more biological perspective, the relative abundance of yellow eels also peaked in the 1980s. Between 1980 and 2008, adult silver female eels migrating downstream from the Potomac River decreased by around 94%. And by 2008, recruitment of young eels in the Potomac was at less than 1/5 of 1980s levels. And so these concerns about increasing demand and declining abundance throughout the 80s, as well as the fact that we realized we really just aren't collecting very much data on eels, spurred a series of management actions. So the Atlantic States Marine Fisheries Commission, which coordinates a lot of the management of several coastal species, formed the American Eel Management Board in 1995. And out of that meeting a few years later, the Interstate Fishery Management Plan for the American eel was published. And among many other things, this plan requires all jurisdictions with an interest in the American eel fishery to implement annual Young of the Year abundance surveys. And it also requires regulations, so things like size and possession limits for recreational and commercial fisheries. And there have been several addendums to the fisheries management plan throughout the 2000s, but the one I really wanted to call attention to was the second addendum in 2008, because in that, the Marine Fisheries Commission really emphasized the need to prioritize upstream and downstream passage of dams as a management strategy. In 2014, the IUCN declared the American eel endangered. However, in 2015, in the U.S. Fish and Wildlife Service most recent status review, they declared that the American eel is stable and not in need of federal protection. Starting in 2012 and every 5 years since then, there have been stock assessments, and the most recent assessment was released in 2023. According to that most recent assessment, the fishery is still considered depleted, and that means it's at or near historic lows of abundance or biomass, but it's unclear which factor other than fishing is the primary cause. The yellow eel population was found to be lower than in previous assessments, and the 2024 commercial landings were at the second lowest since the 1950s at only around 285,000 pounds, so nowhere near that 4 million pounds of peak commercial harvest. The report noted that yellow eel demand has decreased. However, glass eel demand remains high to support the aquaculture industry, although in recent years, the prices for glass eels have started to decline. And specifically in the Potomac, the annual 2024 Young of the Year recruitment was slightly above average, but relatively low in past years. And so what are the factors that are contributing to this depleted status? Certainly one of the big ones is that there's fishing pressure across multiple life stages. So there's been this growing aquaculture industry in Asia that relies on wild-caught young eels that are then raised in farms until they reach a marketable size. And historically, yellow eel were the primary target for commercial fisheries, and although demand for those have decreased, that demand does still exist, and to a lesser extent, there's still demand for adult silver eels. Eel pots are a type of trap that are still by far the most popular commercial method, as well as different types of stationary nets. And because eels are migratory and they tend to be moving in and out of rivers and estuaries at fairly predictable times of the year, the use of these passive fishing techniques are really effective. Water quality and habitat degradation are also factors. So as benthic species, which means they spend most of their time on the bottom of a water body, they're exposed to contaminants in the sediment as well as in the water column. And because they're a lipid-rich species, as we've talked about, they can accumulate contaminants in their tissues at greater magnitudes than other species occupying the same habitat. And these contaminants can impact eels in a number of ways, including, their ability to migrate successfully or reproduce and create healthy offspring. Microplastics and PFAS are emerging contaminants of concern for humans here in the Potomac, but as well as for eels. Eels have been documented consuming plastics, whether that's intentional because they mistake it for food or sort of unintentional through consuming prey. And American eel have also been found to have elevated levels of PFAS in their tissue. Habitat alteration impacts eel at all of their life stages. So just a few examples, sargassum seaweed is harvested in the Sargasso Sea where they spawn, and so this can potentially impact their spawning behavior, as well as the survival of young eels. Things like dredging and filling in coastal areas and loss of coastal wetlands can mean habitat loss for eels in those important transition zones. And altered stream flow can impact how and where eels migrate into freshwater. A few other stressors include climate variability and changes to ocean currents. Those can impact the timing and success of migration. I think Mike kind of talked about larval eels and how they tend to drift on ocean currents because when they're really young, they don't have the ability to swim. So changes in ocean currents can impact how they get distributed. There's also a well-documented invasive parasite that's been impacting eels. And then, of course, predation is a natural stressor for any population, but it can be exacerbated by the presence of invasive species like blue catfish. And the last but certainly significant driver of decline is barriers to migration. Dams and coastal streams and rivers from Florida up to Maine have estimated to have decreased available habitat by over 80% for migratory fishes. And this can be a problem because the concentration of eels below dams can lead to increased predation, competition, and disease. and it can also skew the sex ratios of the population. Turbine mortality can occur while eel migrate downstream at hydropower dams, and impingement mortality is common at water intakes. So I wanted to conclude this section by reiterating a point that I've come across repeatedly in the literature, which is that the American eel population is very data poor. And so all American eel are considered to be a single population, which is unusual in some ways because often a single species has multiple geographically defined populations. But the American eel is considered a single population all the way from Greenland down the US coast into South America and the Caribbean. And we know they all begin and end their life out in the ocean. They migrate potentially thousands of miles into freshwater. And so trying to put a number or a status assessment on a species with such a wide range and such a complex life history that we so far have not been able to successfully track has proved to be an enormous management challenge. Aside from the annual Young of the Year surveys, there are very few fisheries independent surveys that are conducted to specifically target American eel. And the fisheries dependent data that is collected, such as commercial landings, are a start, but the number of American eel commercially harvested doesn't necessarily translate into an estimate of how many American eel there are or would be. And then lastly, data collection largely focuses on coastal areas, but of course we know that eels spawn in the open ocean and they occupy all types of freshwater habitats. They actually occupy more aquatic habitats than any other fish species, which I think is a cool fun fact for you all to take away. And data collection has largely focused on the yellow eel life stage, and we have very little information about the other 4 life stages. And so while these points are generalizations, they hold true for the Potomac River as well. And so we have the annual Young of Year surveys in the tidal Potomac, but beyond that, we're really relying on non-target surveys by state agencies, and especially this historical context that we're talking about to get a better understanding of the eel and restore the native range. So I will give it back to Mike.
Hey, you guys thought you were done with me. Just to kind of wrap things up, what is ICPRB's role in this? Why are we taking an hour of your day to talk about American eel in the Potomac? And it's because, in particular, they are the thread that makes the greater tapestry. We need to look at this organism and see how it connects to the big picture. So there's been some efforts in the past for more eel passage at dams in both the Shenandoah and the Potomac. And there are questions that present themselves locally. Why are there presumably more eel going up the Shenandoah than the main stem Potomac? We don't know. And largely we don't know because there's not enough opportunities for us to monitor. It's that data poor environment that Megan just mentioned. So we want to kind of highlight that the North Branch and other Western Potomac tributaries are priority systems for ICPRB. We're relatively small shop, so the idea of these collaborative projects and shared visions are all the more important. Right now, there's the discussion at Canal Place, the Cumberland Dam, where they've included eel passage language and monitoring language into their project. Their National Park Service is working at Dam 4 right now for an eel passage as well. ICPRB currently has a NIFWIF grant at Dam 5 that we are putting in eel ladder and kind of using congressional funds to bridge all 3 of these projects to try and unify a monitoring strategy. And there's a lot of conversations happening. We're all kind of leaning on each other for resources and know-how. But that collaborative vision to reconnect the middle and western part of the basin is a significant one. And it would actually be the first time in over 100 years, 150 years, where eel would have free passage of the entire length of the main stem Potomac. So it's a lofty goal, but that's the larger vision is there. Right now, we're working on Dam 5, the highlighted box there is where we're taking the old eel ladder, and we learned our lessons that we know the Potomac is a flashy river. We know that there's like significant flooding. So we're taking the old design and improving it with shear pins and flow resistant designs, re-engineering the whole process to get those eel above 5. The same technology and discussion is happening at 4 in Canal Place. We went out and, the world keeps trying to make it difficult for us, but we're obstinate little buggers. We went out, and as the price of materials went up, we went out and recovered some of the old I-beams from the last fish ladder that was washed out in the flood, and scanned those in to be included in part of the redesign. So, as the prices of materials go up, if we have to reuse, recycle, we'll get this thing done either way. That's us pulling all the equipment up behind Dam 5 for the rescan, and that's actually the destroyed former eel ladder that was there. You'll notice in the upper left that white bucket is actually going to be the holding pen that any eel that used the metal column that you're seeing to the middle of the screen, kind of going down on an angle. Any eel that climb up that will be held there. All the fish will be measured and then released upstream. So we'll start having this captive quantification of not only use of the eel ladders and their effective or efficacy, but also we can start looking at population numbers and seeing if there's any changes with all these fish passages going in place. So right now, you heard Megan's review. We've done this literature review focusing on the Potomac, but you have to take a step back and look at the big picture. As she pointed out, this is not a Potomac-specific problem. This is a much larger region, and we're just trying to do our piece here in the Potomac. We've done the data call to just about anybody who would pick up the phone, and we're putting all that data together to see how we can combine it to get a better picture of the region. And this is the important part, and I appreciate everybody on the call today. Following up on this, we're going to start monitoring this eelway, but it's not something that can be done by ICPRB in perpetuity. We're going to need local stakeholders and interested people. I think this is an opportunity. I know there's trout in the classroom and things like that. This is an opportunity for local environmental groups to potentially be involved in a pretty interesting fisheries study. So as this project goes forward, I'll be knocking on doors and kicking around. If you see me, stop and say hi. Now, there's one thing I left out, and I'm going to do this really quick, but the mussel, freshwater mussels, they are an integral part, or the American eel is an integral part of this mussel life history. Basically, these mussels will release glaucidia. They get captured in the gills of fish, and those fish swim upstream, and that's the upstream dispersal mechanism of our filterers. Each adult mussel, this is kind of one of those catch-all facts, but can filter about 18 gallons of water a day. So if we could increase the eel numbers, and potentially we are increasing the mechanism for more dispersal. Why is that important? Well, so this last year, we were also doing mussel surveys with Maryland DNR and Fish and Wildlife and others to get an idea of mussel distribution as well. So we're supporting that project while moving forward with our American Eel Project. These two things are linked, and we want to see if increased passage will have any kind of effect on the freshwater mussel abundance and distribution. And when you look at modern versus historic distribution of freshwater mussels, that western part of the basin is vacant. And that's largely due to things, land use, heavy forestry or deforestation, mining practices, things like that. But when you combine that with putting up fish impasses like these dams, we're kind of hitting that western part of the basin from two different angles. And we're hoping that all of this will kind of lead to that future objective of we'll see whole system improvements, not just single species focused improvements. And with that, that's called a teaser, guys, because the next presentation on December 2nd is going to be me again talking about reconsidering connectivity, a North Branch Potomac case study. And you'll hear me talk more about things like the freshwater mussel distribution, as well as the importance of getting eel and protected habitats and things like that. So a cliffhanger, if you will. I'll stop talking, and I think we may have time for questions. I'll kick it back to you, Renee.
Yeah, thank you, Mike. That was so interesting. So we have a couple comments. If you have any questions, please put them in the chat right now. Apparently, we have found you a long lost relative. Kevin McLean has also traced his roots back to John Howland. So that was interesting. Who knew you had such a
That's funny.
connection?
Yeah.
And then Jim Cummins, hi Jim. He asked something in the Q&A, and he said, "Have you ever tried capturing eels at night?" I haven't, but including the extra density of eels back in the 1700s, there might be something to that night method.
Yeah, well, I know one of the things, and I haven't found a good woodblock drawing or sketch of this, but there's an anecdote of horses being afraid to cross fords, to cross small streams, because the stream was writhing with eels. There were so many there that they actually freaked out the horses, and that the wagon wheels would squish these things as they go across. So, I haven't tried catching them at night, but if the abundance was enough to freak out a horse because it was a black, slimy, bridge or road crossing, uh, boy, I guess shooting fish in a barrel. I don't know. They're saying there's got to be a saying about that, but yeah, I hear you, Jim.
If anyone has any questions, like I said, put them in chat. I have a question that I was thinking about that I've always wondered about. The weirs in the river, those kind of V-shaped things in the rivers, like logistically, how do they work? Like, are the eels going up in the middle, or how does that work?
Well,
Do you know?
no. So again, there's a seasonal component, and then there's sort of a mechanical component. The seasonal component is if you have the silver eel moving downstream, those bigger boulders, those bigger fish weirs, they're going to be moving downstream, and when those rocks are slightly emergent, the fish are just going to keep trying to find their way through, and they keep going further and further down to the point. And at that point, that's where you'd have somebody with a fish gig or baskets or things like that, where those eel are going to go down and be captured at the funnel point. You also could have people spread out along that ledge, corralling them more central. But seasonally, you would be thinking about, the silver eel being kind of the focus of capture. In the fall, like I said, sort of the opposite of the shad focus in the spring. And then the other thing is that those things you could always fish them year round. It wasn't like they were only going for eel. So that same mechanism of kind of the funnel choke point was going to work for other things as well. Heck, if you want, we could go out in the river and give it a try one time. It's not such high technology. We can't do it again.
I would love to. That sounds like fun. All right, we do have one question in chat. How can you volunteer to count eel?
So let us get the thing built first. We're putting all the pieces together, but I do want to start ringing that bell now that we are looking for it. So I would say keep an eye on ICPRB's website. I know I'll be bugging Renee in the communications department when it comes time to start training people and identifying folks across the basin to sort of pick this up. That's definitely going to be one of the most, like, it's definitely going to go through the communications department. Hopefully I'll be seeking folks out as well. So get our names, keep asking if you want, or keep an eye on the website.
All right. Somebody asked, how does ICPRB plan to help migrating adult eels? Downstream migration? Question mark.
Yeah, so that's actually a really interesting point. Right now, the power stations in the Shenandoah and the Potomac will actually shut off to improve survivorship of the eel moving out. One of the issues that was discussed back in the 90s, and when the last eel ladder got destroyed and the project kind of lost its momentum, one of the other issues was this concept of impingement. Are there places where withdrawals are affecting the outward migrating silver eel? And given the percentage of the historical population and their ecological role, I think it's something that needs to be reinvestigated, and then potentially discussed. We'll go through the coordination with all the river stakeholders and do what ICPRB does best. But right now we really need to get some data points.
Yep. All right. And one more question from Jim. And for those of you not in the know, Jim is a retired aquatic biologist from ICPRB, and he worked very hard on that shad project that was mentioned in the very beginning of this webinar. So Jim asked, there we go. Regarding the age of the Swedish well eel, did anyone note how would they have aged an eel back in the 1850s? I think that was around the year that you mentioned.
So that was, let me pull up the note real quick. The Swedish eel was 1859 when it was thrown in. It was 155 years old. So that fish was aged around 2000. So it's not that this was, they were trying to figure out the age 150 years ago. This is a relatively modern story.
Okay.
Yeah, it looked like the
Thank you.
7th of August, 2014 was when the owner of the property reported that the eel was found dead. So yeah, 2014, 2015 was when the work was being done to age it.
All right. I don't think we have any more questions. Thank again to all of our speakers, Megan and Mike. And like Mike mentioned, join us for any of our future webinars. We have several coming down the streamline. And with that, we will end our webinar. Thank you very much.